Welcome to my presentation. In this presentation, we shall see examples on evaluating logarithms. Let's say we want to evaluate this logarithm here, log 27 divided by 64 to the base b is equal to 3. Let's say we have something of this type. So as a first step for the solution, we're going to write this one as follows. We can express this logarithm as an exponent as follows. 27 divided by 64 is equal to b to the power of 3. Now we want to look at 27 and 64 and then be able to express it as powers. Express it as powers. One way of looking at it is as follows. Step 2, we'll write that as step 2. We want to find the value of b. In here, let me go back here and then say we want to find the value of the base. Find the value of the base b. Find the value of the base b. So to do that, we're going to write this one out as follows. If we want to find the value of b, we can write this one as cube root of 27 over 64. If you take cube roots on both sides, the value of b comes out as b to the power of 1, or just b, is equal to cube root of 27 over 64. Now we want to look at 27 and 64 and then be able to express it as powers of some number. So let's look at 27. 27 we can write as 3 to the power of 3, isn't it? 3 times 3 is 9. 9 times 3 is 27. Similarly, 64 we should be able to write it as a power of a number, some power of some base number. We can write this as 4 to the power of 3. If you look at it, 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So therefore, this problem we can write this as follows. b is equal to cube root of, for 27 I'm going to write as 3 to the power of 3, and for 64 I'm going to write that as 4 to the power of 3. So now it is just a matter of simplifying these numbers. b is equal to, I can write this as 3 to the power of 3 divided by 4 to the power of 3. This whole thing is raised to the power of 1 over 3. I can express, if I have cube root of x like that, I can express this radical term as an exponent as x to the power of 1 over 3. I can always write a radical in terms of an exponent. I can always express an exponent as a radical. So these are reversible reactions. These are reversible reactions. So therefore, I can simplify this as follows. b, the value of b is going to be equal to 3 to the power of 3 to the power of 1 over 3 divided by 4 to the power of 3 to the power of 1 over 3. Therefore, we know one of the rules of exponents is telling us that if we have a to the power of m and this exponent is raised to another power n, we're going to write the base once and then multiply the powers like that. And therefore, we can write this one as 3 to the power of 3 times 1 over 3. We are multiplying the powers, and in the denominator we have 4 to the power of 3 times 1 over 3. And when we simplify this, the 3's cancel out, the 3's cancel out here, and therefore we are left with 3 to the power of 1, which is 3, and 4 to the power of 1, which is 4. Therefore, the value of b is equal to 3 over 4. Value of b is equal to 3 over 4. This is the way we want to be able to find the value of the base in this case, and therefore this is how it is done. So in my next presentation, we shall see more examples on evaluating logarithms.